Now the question says a stone is projected horizontally from the top of a tower with a speed of 4 meters per second, lands on the level ground at horizontal distance 25 meters from the foot of the tower. Calculate the height of the tower. We have to calculate the height of the tower. Now, as you can see, this question is talking about when a body is projected from a given height. Do you understand?
Okay. Yes, sir.
Now, if a stone is projected, let's say you are the one standing on this height. You are the one standing on this height, and you
Yes,
projected
sir.
a stone, and the stone landed at this point. And according to this question, you are standing on this height that we don't know the how high this thing is. So let's put question mark there.
Okay.
And according to the question, it lands there at a horizontal distance 25 meters from the foot of the tower. If this is the foot of the tower, and it's 25 meters. The stone is 25 meters from the foot of the tower. And the stone is projected horizontally, as I explained at the beginning. The stone is projected horizontally with velocity of 4 meters per second. Let me write it in a proper way. Let's say the velocity in horizontal direction is ux, and it's 4 meters per second. So they want us to calculate the height of the stone. Sorry, height of the tower. And g is given, it will always be given as 10 meters per second squared. So we want to calculate the height. Now, if we go back to the discussion in the notes, let's quickly check. Now, for this type of projectile, you make use of, you can use either this or this formula. But what will make you to choose the formula to use is the parameters. As you can see in those parameters, we don't have time there. So this is not appropriate. We can't use this one because time is not there, except you want to first look for the range or look for the time and later find the height. But since we have a formula that can handle it for us, there's no point going through all those stress. So let's go back. You can calculate your height using this formula. H equal to gr squared over 2u squared. Remember, this u is in horizontal direction, so that's why I put x there. Now, this formula is also a derived formula. It is derived from two formulas. And let me quickly show you those two formulas. Though one of them is in the notes, while the other one is not in the notes. One of the formula is this t, which is equal to 2h over g. And the other one, we have r equal to ut. So the combination of these two formula is what gave us this, but we are not deriving any formula here. We are solving problem. We're only solving problem. So if you use this formula, you are looking for h. Let's substitute. H will be equal to our r is 25. Our g is 10. So we have 10 multiplied by 25 squared. Everything over 2 multiplied by our u is 4. 2u squared. If you press your calculator, what will you have?
My calculator. 10 times 25 squared. That's 6,250.
So what will be the final? Divided by the denominator.
6,000. What do I call that again? $195.3.
195.3. Okay. As simple as this question appears, I want to believe this is the question from I think 2014. One of the questions from part A, theory in 2014. Quickly copy the solution. Now, if you look at this question, it's also very similar to the first one that we saw. We have a particle that is projected horizontally at 15 meters per second from a height of 20 meters. Calculate the horizontal distance covered by the particle just before hitting the ground. Like I said earlier, it's not all the time you are going to be sketching the diagram. I'm just doing that for the sake of explanation and for you to know the type of projectile we are dealing with. Now, in this case too, the body is projected from a given height to the ground and with horizontal velocity of 15 meters per second. It's not in all text that you are going to be seeing horizontal velocity as ux like this. Sometimes you just see only u. But I'm just differentiating because of the next part we are going to talk about. Here, you are given height. The height is equal to 20 meters. And they want us to calculate the horizontal distance covered from the foot of that platform before the body hits the ground. So we're still going to use the same formula we use in the other one. Or let me just let me apply the second approach. So here, let's use two formulas to solve this one so that you will know how to handle. You now choose anyone that you're comfortable with. Now, you know, time is not given in this question, but we can quickly look for our time in this question and now use the time to find our range. How do we do that? Remember that time t equal to root 2h over g, right?
Yes, sir.
Okay, it's one of the formula we've discussed. So using this one to find your time, you can have, we have our h to be 20, so 2 multiplied by 20 over 10. So that is 40 over 10, and t will be 2 seconds, right?
Yes, sir.
Very good. But t is not what they ask us to find. T will be equal to 2 seconds, but they ask us to find range. But you know that this range is horizontal distance, which we discuss in our linear motion. This formula for horizontal distance, are we? But since we don't have horizontal acceleration, our A will be equal to 0. And this formula becomes S equal to UT. Because the whole of this part will become 0 if our A equal to 0. Because we don't have horizontal acceleration. The only acceleration we have for projectile is vertical acceleration, which is acceleration due to gravity. And this U, because it is a horizontal component, we can call it UX. That is the one that is given in this question. So our S is the same thing as our range, R, because it's horizontal distance. So we can say R equal to UXT. So we can use this one to find our R. R will now be equal to 15 multiplied by the time we calculated now is 2, have we? And R will be equal to 30 meters. So this is the answer we are looking for. So here we only apply two formulas. We will first use this one to get our T, and later use this one to get our R. S is the same thing as R because it's horizontal distance. Or you may choose to use this formula H equal to GR square over 2 U square, and make R the result of the formula. You will still get your answer. You will still get the same answer. Is
the
that
answer is 30. The final answer is 30.
Yes, the final answer is 30.
Yes, sir.
Hope is clear.
Yes. Yes, sir.
Okay. Now, this is the third question, and the question says, a tennis ball is hit with a velocity of 3 meters per second at an angle 60 degrees to the horizontal. Calculate the time of flight, maximum height, and the range. G is also given as 10 meters per second square. Now, if you look at this question very well, You will agree with me that the type of projectile we have here is this second type we discussed. That is when the body is projected at an angle to the horizontal. You know, when you hit a tennis ball, either lawn tennis or table tennis, you expect it to follow this trajectory. It will move this path, and the maximum particle distance travel before descending, we refer to that as maximum height. Are you with me?
Yes.
And the velocity of projection is given as 3 meters per seconds in this question. And this theta angle of inclination to the horizontal is given as 60. And our G is 10 meter per second square. Okay. Now the first question asks us to find time of flight. And the formula is 2u psi theta over G. Substituting the parameters given to us, we are going to have 2 multiplied by u, which is 3, multiplied by sine 60, everything over G, which is 10. And what would that give to us if you press that on your calculator? What do you have for that? The answer should be 0.52 seconds. For maximum height, the formula is u square sine square theta over 2g. So let's substitute the parameter. Our u is 3, so let's have 3 square multiplied by. Now this time around, be careful how you handle this. Put sine 60 in a bracket and square it. That's the meaning of sine square theta. Don't square
Okay.
60 before you find sine. Don't square 60 before you find sine. Put sine 60
Okay.
in a bracket and now find the square of sine 60. So if you press your calculator, we are going to have
0.886. 0.866.
which one is 0.866 there? Sine 60 square
Sine
or
square,
final
yes.
answer?
No,
Okay,
sine 60 square.
the final answer is supposed to be 0.34 meter.
What is the answer?
And for
Okay,
the
yes. 0 point. Yeah, I'm getting 0.8.
0.8,
0.38.
check it very well.
Okay.
Oh, that should be 0.34. The answer is 0.34, not 0.8. Now for the
I found it.
range, the formula is u square sine 2 theta over g. That's for the range. And if you substitute the values, you are going to have r equal to our u is 3, so 3 square multiplied by 2 theta will be 2 times 60. So that is 120. So you have sine 120, sine 120 over 10.
So you have already used it by 3 instead of by 2. You used
I
by
use
2 instead of.
sorry for that. Sorry. This will be 3 squared. So this will be 0.78 meter.